Hi folks, I thought in this video I would show you the bicycle itself that I plan to turn into the e-bike. So there it is in the background. I'll show it to you in better detail, but first I've been working on the battery and so here's the battery. It's not done yet by any means, but the basic shape is there, and I'm hoping to mount it right in here. And as it turns out, all those painstaking measurements I took were actually correct. It will fit. I'll build a little box around it and it'll fit around in here somewhere. So I'm pretty jazzed about that. I'm still not sure. Hopefully I can fit the BMS in there. I haven't bought it yet, so I don't know how bulky it is, but anyway, that's kind of cool. It's going to fit right in there. The original design had 6 batteries on the, looking like panniers, but that was going to be like 300 cells, and that was because I was using old laptop batteries at only something like 500 to 1,000 milliamps each, and so I was going to need a ton of them to come up with the ability to produce as much current as I wanted. But with these 4.4 amp cells, I don't need near as many to get the amps, and the watt hours will be fine. Those never were a problem. But anyway, let me take the bike outside where there's less mess and better light and show you some details. Okay, what I have here is a Rally Point mountain bike. Got a neat little metal, like logo thing on there. Made in China, so you know it's good. And 18 speed. I got this fixed up by a friend of mine who is a former bicycle repair guy. And I put on a rack in the back to hold e-bike stuff, and I bought a riser and my own set of handlebars. The old handlebars were like that or something, and I've got short little arms and I could not hardly ride this thing, but I got the bike for free. So, and then yeah, my friend put on a custom length cables, and he made sure all the chain stuff is working right and all the bearings and whatever. And then and I got a custom seat that doesn't hurt me while I ride. So that, I guess, is about it for the bike. I don't know, seems like there was more to say, but the bike was free. I've been collecting accessories like these guys for the last several years. But yeah, it's all in good shape. Just can't get up the darn hills, so. But there it is. That's the bike that will become the e-bike. Hi folks. Here's another bit on the battery. So in the last clip I was talking about keeping track of the individual cells on a spreadsheet. Just real quick, here is the spreadsheet, and so I have all the pertinent information on each cell here. Everything that's highlighted green are cells that are actually in use, and then I have written down what device they're in. And then over here, the ones in red are cells that have failed since being tested good, and why they failed. So I thought this isn't really a necessary thing if you're harvesting cells, but it's just something I like to keep track of stuff. So getting back to the actual battery, let's see, here we go. So I've shared this picture in the forum before, but this is kind of a rough sketch of what I expect the bike to look like. And I went and measured the angles and the lengths of the bicycle frame, that triangular part where I hope to put the battery. And this is a little CAD program where I can actually draw things precisely to scale. And so these green outer lines represent the inside of the frame cavity. So like the edge of the tube, and then these white lines represent a 1-inch buffer, or an approximate 1-inch buffer anyway, between the edge of the, between the frame and the battery that I'd like to keep, just so I have a margin of error. And then all this red stuff, the circles are individual 18650 cells, measured and drawn to scale, and then the squares are the measurements I have on the plastic battery holders that most of us use. And sure enough, if you put them in this kind of shape here, 128 cells will fit in this cavity just fine. So that was the first question, is can I fit the battery where I want to fit it? And the answer is yes. So moving on, back to this presentation. So here you can see the rough shape of the battery in this little non-scale sketch. And here's a more detailed view of how I intend to make the batteries. So you got the red cells, which are positive ends, and black cells, which are negative ends. And then, I got them grouped here by series. And then I have a mirror image on the other side, of course, with the polarities flipped. And this helps me visualize how the different cells are going to go together. And then here's another representation. This is all stuff I've done to help me keep track of it. It doesn't necessarily need to make sense to anybody else, but this is what I've done to help me. And so yeah, these are just little block representations of the series. And then I've got these sort of copper colored lines representing connections from one series to another. So this would be the right side of the battery. This down here would be the left side of the battery, and then here's the two poles of the battery, right? And so getting into a little bit more detail, I need to actually design the bus wires so that every cell can actually connect to them. And you'll see in a later clip, I think, the actual result, or at least part of it, of how this is. It turns out pretty close, but yeah, these weird shaped series are going to require weird shaped bus bars, unfortunately. But the idea is that every series has at least 2 segments of bar going across it, and then of course I'll just use a single wire to do that, just to make sure everything's all, I don't know, balanced, I suppose. Oh, this side, by the way, is not fused. All the fuses are going to be on the other side. So this is just little wires connecting each cell to the larger bus wire. This side, on the other hand, is going to be fused. So I got little gray lines representing the fuses that are going to connect each cell to the bus bar. Again, some of them are really funky shaped because I got really funky shaped series. Some creative problem solving has been necessary. But again, here's the positive pole and here's the negative pole.
I knew there was something I forgot. I wanted to mention real quick that I ran my cells through the cell repacker on the forum, and the nice thing about having your milliamp hours written down on a spreadsheet is you can copy them and then paste them right into the form. Let's go here. Oh, so you can paste them right in here, and this is what it looks like. And then tell it what series and parallel you want, generate packs, and this is what it gave me. I'm not exactly sure what divergence and deviation mean. I think divergence is comparing the total capacity from one series to another. And I think deviation is how far an individual cell varies within the series. I think that's how that works. And as you can see here, the repacker managed to get zero divergence. So the milliamp hours were all the total milliamp hours were all close enough that it was able to get all of them to 3,000. There are 33,741 milliamp hours. So that's kind of cool. And then it gives you from there you can highlight and unhighlight these cells. And that's what I did to as I got each cell into its position, I went ahead and highlighted it to let me know that I got that one. And then down here you can copy the new order and paste it right into your spreadsheet again. So find my spreadsheet here. So paste it right in there, and you can see the numbers here agree. The sum of all the milliamp hours in each series is the same, and so the average for the battery is the same. So I have 33.7 amp hours in my battery. So that's I meant to talk about that in my other clip and completely forgot. But yeah, that cell packer or repacker, whatever it's called, repacker is pretty handy, especially if you have a wider variety or a wider range of capacities than I do. Like my weakest one is probably something like this 1416 or 1365 is probably my weakest cell, but my strongest cells are 22 something, 2250, 2254. So there's a bit of difference in there, but with the repacker it orders them for you so that each series has the same capacity, and that will help with keeping it balanced without having to balance charge it. So that hopefully, of course, these numbers, you test a cell 10 times and you're going to get 10 different numbers, right? So this is not an exact science. The cell is going to behave differently every time you charge it. But at least, this gives you a step in the right direction. Anyway, this is the repacker function on Second Life Storage, and you can see that there's a link at the top of every banner. It's pretty darn easy to use if you've already, especially if you've already got your milliamp hours in a spreadsheet. If you don't, well, then you'll have to manually type them in, and in a large battery that could, yeah, since I have mine all, oops, that's the wrong window. There we go. Since I have mine all written down anyway, it's just a matter of copying and pasting, and I put mine in a little box anyway and do my own calculations here, which, yeah, this I showed in another video, but this one there are no more yellow cells. I've got everything all sorted out the way I want it.
Okay, I'm not sure where this will go in the video, but here is a real-life version of the design that I've been fiddling around with on PowerPoint. And specifically, here's the back side of the battery, the unfused side, that I am soldering together with just small wire and bus wire. So here's a series, and here's a series, and they're connected together. This series is now connected to that series. Then later I'll connect these two series and these two series, and then we flip it over and kind of do the same on the other side, except with fuses. And of course we'll do different series so they don't blow up. But anyway, so this is not the most elegant solution, but because these series are in funky shapes, I needed a funky shaped bus bar to go around them. The idea is every individual cell should have a small wire going, at least one small wire going to the larger bus bar. And the reason that I do that, I guess, is the same reason a lot of people do that, is so you don't have to try and solder the heavier gauge wire to the individual cells, because that takes a lot more heat, and that means that you're heating up the cells longer, and that means that heat can potentially penetrate through the jacket into the actual reactive stuff, and you don't want that because that'll start damaging the individual cells. So the idea is you solder the little wire to the cell, and that doesn't hardly take any time, and then you can spend a larger portion of your time soldering the small wire to the big wire, and yeah, nobody cares because all the heat's going to get soaked up by the big wire, and everybody will be happy. I'm not going to show you how to solder because that's already been done. Check out Daniel Romer's videos on how to solder cells if you want to know how to do them properly. But I do mostly the same technique he does. I pre-solder the tips, and then I go through and solder, well, I bend the bus wires in place, and then I go through and solder all the small wires over the bus wire so it kind of gets tied down, and then I go back through and solder the wires to the actual bus bar later. And what I found is, even though I'm using flux core solder, it really helps if you paint on a little bit of extra flux at each soldering point. It really helps the solder to bond to the larger wire. And also, because these are pre-soldered, there's no more flux left when you put these little wires on. So I like to put just a little bit of flux on the wire, and then it's stuck. The solder just wicks right up onto the wire in 9 out of 10 cases anyway. And yeah, I'm still practicing, but if you saw my first attempt at making a battery, this is perfection compared to that. I I was doing everything wrong. But anyway, so this is the basic shape of the battery, and for mounting it, I drilled some 1/4 inch holes in the cell holders, and I'm going to put some kind of insulated, like an insulated threaded rod or something through there. So this back half without the fuses, I can bolt that to the back of the battery box, maybe, with some foam, to protect it a little bit. But yeah, I can put that there, and then all the fuses will be on this side. So if I have to replace fuses or replace cells, well, if I have to replace cells, I got to take the whole thing out anyway. But if I just have to replace fuses, then say like if it gets physically damaged or something, and it's not an electrical issue that I have to troubleshoot or something. But anyway, I at least have access to all the fuses up here, and I'm going to do as many solders here as possible, although I will have to solder some wires in the back for the balance leads. Um, but yeah, the big positive terminal will be here, and the big negative terminal will be here, and those will both be accessible. And I don't know, I might even be able to put a big old fuse in here. It all kind of depends on how much room I have once I built the box, because it still has to fit in that triangular space of the bike, so I can't go nuts on this. I still have to watch how bulky this gets. So but anyway, so that's my progress so far, the physical construction of the battery, and some of the soldering done. Hey folks, hopefully this is in focus. I just wanted to show you the finished battery. I mean, right now it's just the battery. It doesn't have any cables or BMS or anything like that. But the battery itself is all soldered up and complete. Next steps are add the BMS, add the main fuse, balance wires, terminal wires, all that good stuff. Build a box for it. Well, I'm waiting. I have the fuse. I bought a 60 amp fuse. So I'll be adding that in as a on the positive side over here somewhere, and then the BMS hooks to the negative. So this is the side with all the fuses, individual fuses here, 3 amp fuses on each cell, and the other side is just bus wire, and that way this is kind of a fairly heavy thing. And this way I can lay it on one side while I work on it and not have to worry about crushing these fuses. And also when it's in the box, the panel covering this side, I'm going to make that relatively easy to remove so I can get at these little fuses if I have to. And then I'm going to put as much wiring on this side as I can. So this will be kind of the access side. And then the other side will be kind of up against the box, but I do tend to put some standoffs so that it's not right up against the box. But anyway, so there's the finished battery. It turned out mostly like the schematic that I drew up, with the exception of this bus wire here. I realized that only one segment of wire was going to cross from one series to the other, and I really wanted two. That way roughly half the amps are traveling through each segment of wire, since they're technically in parallel. So I redesigned it so that it would still reach all the cells that it needed to, and now it has two sections that cross from this series to this series. And so now all of my series connections have at least two. There's one there, and this one has actually three, because these two series are kind of weird shaped. And over here this one has There's one, and actually there's another one. So that one has 3. This one has 2. That one has 2. This one has 3. So they all have at least 2, and some of them even have 3. So I'm pretty happy with that. But that's about it for the battery for now. So I hope this was interesting, and thank you for watching.